So alternative A cross B is equals to minus of B cross A. This means that vector product is not always commutative. That means A cross B is the negative of B cross A. This is always true. So it is true. B, A cross B plus C. The cross product is distributive property, which is equals to B cross A plus A cross C. But this is not correct, or this is not true, because if we do from the alternative B, A cross B plus C, A cross B plus vector C is equal to A cross B plus A cross C. But since the vector product or the cross product is not commutative, A cross B is not equal to A cross B is not equal to B cross A. So alternative B says A cross B plus C is equals to B cross A plus A cross C. So this alternative is not true. Alternative C says that A is perpendicular to B. That means if vector A is perpendicular to vector B, this implies that the magnitude of A cross B is equals to the magnitude of A times the magnitude of B. This is always true. It's also true because A is perpendicular to B means the angle between A and B is 90 degrees. That is, A and B are orthogonal to each other. Then if A and B are perpendicular to each other, the angle between the smaller angle between A and B is 90 degrees. That means A and B are orthogonal. So the cross product is of A and B, which is given as the magnitude of A times magnitude of B times sine of angle between them, is always given as the magnitude of vector A times the magnitude of vector B, because sine of theta, since sine of 90 degrees equals to 1. So alternative C is also true. But when we come to alternative D, if two vectors A and B are parallel, that means vector A and vector B are parallel to each other, this means the smaller angle between them is 0 degree. That means the cross product is of the two vectors A and B, A cross B, which is given as the magnitude of A times the magnitude of B times sine of theta between them. Since theta is equals to 0 degree, so sine of 0 is exactly, sine of 0 degree is exactly 0. So this number becomes 0. That means from the alternative D, if A is parallel to B, this implies A cross B is 0. It's also correct. So the not true answer from the given alternative is alternative B. That means the vector product is not commutative, so we cannot interchange the places of A and B here. So this is wrong. So the correct answer is B. B is not true. The work done by force F in moving the objects from its initial position R1 to R2 is the dot product is of force and the displacement traveled. Displacement traveled by the object is the position vectors, or the difference of the position vector R2 minus R1. So this is the final position minus initial position gives us the total displacement of the object. So the total displacement is equals to, we subtract the position 1 from position 2. That means we have 1.2 minus 0 is 1.2 along I, and 2 minus 1 is 1, that is plus j, and 1.5 minus 1.5, which is gives us 0k. So this is the displacement traveled by the objects from this position to this position by the force F. So work done is the dot product is of force and the displacement is, so the force is just minus I plus 2j plus 3k dotted with the displacement is 1.2 plus j plus 0 k meter, which is equals to 1 times minus 1 times 1.2 is minus 1.2, 2 times 1 is plus 2, 0 times 3 is plus 0, which is equals to minus 1.2 plus 2 is equals to 0.8 joule. This is the amount of work done by the force F in moving the objects from its initial position R1 to R2. So the answer is 0.8 B. So this question is about resolving a vector into its three components, that means x, y, and z components in Cartesian coordinate system. So we can resolve a vector into three components: component along x, the component along y, and the component along z. So magnitude of vector A is 100 meter. It is a displacement vector. So I can resolve, or I can find the components of x, which is vector A, which is along x, along y, and along the z-axis. So the vector A makes an angle of 60 degrees with the z-axis, and vector A, the components of vector A laying in xy plane, making the angle of 30 degrees with the x-axis. So mostly we consider the angle which A makes with the z-axis is considered at theta, which is 60 degrees, and the angle which the components of vector in xy plane makes with the x-axis is considered commonly as a phi, which is 30 degrees. So then we can easily calculate that the components of vector A along z-axis, which is AZ, is easily calculated. That is, AZ is equals to magnitude of A times the cos of theta, which is equals to 100 meter times cos of 60 degrees. So since cos of 60 degrees is equals to 0.5, or it is half, this value gives us that 50 meter. So the component of the vector along the z-axis AZ is equals to 50 meter k. So we got the one component, or the z components of the vector. So the components of A, which is laying in xy plane, is directly calculated. This component, or the length of the vector, which is magnitude of A times the sine of theta, which is 100 meter times sine of 60 degree. So since sine of 60 degree is equal to 0.866, so these values become 86.6 meter. But this is not x, not y, but we can resolve still this component is into along x and along y. So the component along x is given by the magnitude of the component is, or the magnitude of the component of vector A, which is laying in xy plane, times the cos of this angle. So directly we can say that A times sine of theta times the cos of phi, or we have already calculated this one. This value is already 86.6 meter times cos of 30 degree. So cos of 30 degree is equals to 0.866. So this value become, if you multiply together, you get 75 meter, which is along the x-axis. So 75 meter along the x-axis. And the y component is the magnitude of A, or the values of the components of vector A, which is lying in xy plane times the sine of phi. So if we substituted this value, already we have calculated this as 6.6 meter times sine of 30 degree, but sine of 30 degree is 0.5. so if you calculate this value, you get exactly 43.3 meter along the y-axis, or along J. Therefore, the components of A along x is 75 meter, and the components of A along y-axis is 43.3 meter, and the components of A along the z-axis is 50 meter. So vector A is written as 75I plus 43.3 J plus 50K meter. So the answer is B. The work done by force F is equals to 4I Newton in moving the objects from x is equal to 0, that is from origin, up to the x is equals to 5 meter is, you know that work done is the dot product is of force and the displacement, but our displacement is equals to the vector differences of the position function, that is x final minus the x initial, but the force is also along x-axis and the displacement is also along the x-axis, which is equals to 5 meter minus 0, which is 5 meter along the I. So then if we directly substitute the values of force and the displacement, this is 4I Newton dotted with 5I meter, or 5 meter along the I. This is equals to 20 joules. So the answer is on alternative D. Three vectors A, B, and C in xy plane such that A plus B minus C is equal to 0. Then what is the unit vector along the vector C? So firstly we have to find the vector C, which is, since A plus B minus C is equal to 0, then vector C is equals to vector A plus vector B. Then if we directly substitute the place of A and B, that is the sum of vector A and B, 3I minus 2J plus minus I minus 4J, which is equals to, we add I components together and the J components together. That means 3 minus 1 minus 2 minus 4. So this is finally equals to 2I minus 6J. Vector C is equal to 2I minus 6J. Then the unit vector of C is vector C divided by magnitude of vector C, which is equals to 2I minus 6J divided by under radical of 2 square plus minus 6 square, which gives us that this is 4 and this is 36. So this is equals to 1 over under radical 40 into 2I minus 6J. But still we can simplify this. Radical 40 is 4 times 10. So under radical 10 times 2, this is 1 over 2 radical 10. And also we can take 2 as a common. that is 2 into I minus 3j, and these two cancel each other, and we have left with unit vector C is 1 over radical 10 I minus 3j is the unit vector. So vector C, unit vector of C is equals to 1 over radical 10 I minus 3j. Still we can rearrange. That means unit vector C is equals to under radical of 1 over 10 I minus 3 over radical 10 j. So the answer is D. Three vectors A, B, and C such that A dot B plus C is equal to 0. Then what is the vector C? From the given, we can see that vector C is the vector which is laying along the x-axis. That means C has only a single component. So vector C can be written as Cxi 0j plus 0. Okay, that means vector C has no y and the z component, is only laying along the x-axis. So then we can see that vector A dot B plus C is equal to A dot B plus A dot C from the distributive property, and this is equal to 0, and we can find the values of vector C from this equation. Vector A dot with B plus vector A dot with vector C gives us that this is 3 times minus 1 is minus 3, and minus 2 times minus 4 is plus 8, and 1 times 3 is plus 3. This is A dot B plus 3 times Cx is 3Cx, and 2 times 0 is 0, and 1 times 0 is 0, and this value must be equal to 0 according to the given equation. So this value becomes 3 and minus 3 cancel, and we have left with 8 plus 3 Cx is equal to 0. That means Cx is equals to minus 8 over 3, which is the components of the vector laying along the x-axis. Since vector C has only the x components, so C is equals to Cxi. That means minus 8 over 3 I along the x-axis. So the answer among the given alternative is on D. So velocity of car and velocity of a bus are given from the ground observers. So what is the velocity of the bus from the car's driver, or according to the car's driver? This means that the velocity of the bus with respect to the car, or the relative velocity of bus with respect to car, is the vector differences of the velocity of bus and the velocity of the car. That is, the relative velocity is always the vector differences of the two velocities. So velocity of bus is given by minus 5 I minus 4 j meter per second minus, and the velocity of car is 3I minus 2j meter per second. So we collect the I terms together and the j terms together. So the I terms are minus 5 here, minus 3, and minus 4, minus of minus 2 is plus 2. So finally I get that minus 8I minus 2j meter per second is the relative velocity of bus from the car's drive. So the correct answer from the given alternative is on alternative D. Okay, two vectors A and B are given. Vector A is 3i minus 2j and vector B is minus I minus aj. Both vectors are lying in xy plane. That means they have x and y components such that A plus B is equals to 2i. Then what is the values of A? So we can add these two vectors together. So A plus B means that is 3i minus 2j plus minus I minus a j, which must be 2i. So this means that we add the I terms together. 3 plus minus I, that is I terms and j terms, which is equals to 2i. This is 3 minus 1 and j terms are minus 2 minus a. But this is equals to 2i. So this is 2i minus 2j minus aj, which is equals to 2i's. That means we have 0j here. We have 0j here because the j component is not here. So this is equals to, just from this equation, just we can see that 2i is equals to 2i from both equations. This is true, and we leave it like that. And then from this we can see that minus 2j minus aj is equals to 0, because here we don't have the j component is here. So this means we can remove j from both sides by doing or transferring this terms to this side. That is minus 2j is equals to aj. Just I can cancel a, and the values of a is equals to minus 2. That is the final answer. So a must be minus 2 for the two vectors a and b. That is a plus b is equals to 2i. So the correct answer on the given alternative is minus 2, which is C. For two non-zero vectors A and B, both are different from 0, then if the sum and the difference of the two vectors are equal in magnitude, what can you conclude about these two vectors? So it is obvious that if the sum and the differences of two vectors are equal in magnitude, the vectors are orthogonal or perpendicular to each other. So just we can prove this mathematically by using the cosine law. That means the magnitude of a plus b is equals to and the radical of the magnitude of a square plus the magnitude of b square plus twice of magnitude of a and b times cos of theta, where theta is the smaller angle between the vectors a and b. And a minus b, the magnitude of a minus b vector is equals to the magnitude of a square plus the magnitude of b square minus twice of magnitude of a and magnitude of b cos of theta, and the radical where theta is the smaller angle between the vectors a and b. So since the sum and the differences of the vectors are equal in magnitude, these two numbers are equal. That means we can say a square plus b square plus twice of ab cos theta, and the radical is equals to a square plus b square minus 2 ab cos theta and the radical. So I square both sides and break these square roots and we have left with a number that is magnitude of a square plus magnitude of b square plus twice of magnitude of a times magnitude of b cos theta is equals to magnitude of a square plus magnitude of b square minus twice of a b cos theta. We get this value finally. So then I collect the like terms together. That means the terms with cos to one side and the terms with a and magnitude of b to one side. So if I transfer the minus 2ab cos theta to this side, I have twice of magnitude of ab cos theta plus twice of magnitude of ab cos theta is equals to magnitude of a square plus magnitude of b square minus, if this is transferred, a square minus magnitude of the b square. So this terms become 0 and 2 plus 2 is 4. I have 4 times magnitude of a times magnitude of b cos theta is equals to 0. Then if I divide both sides by 4 times magnitude of a and magnitude of b, cos of theta is still 0. Then our theta become the cos inverse of 0, which is 90 degree or pi over 2. So since the smaller angle theta between the two vectors a and b is 90 degree, then we can conclude that vector a is perpendicular to vector a, or a and b are orthogonal to each other. The answer among the given alternative is on D, which says a and b are orthogonal to each other. The vector which represents the position of a vector in relation to another object is called dash. So it is obvious that the vector which represents the position of an object is with respect to another object or with respect to another point, is maybe some reference point from origin, is called the position vector. So the answer is B. Position vector is always the vector which represents the positions of an object is with respect to another object or another point. But unit vector is a vector with a magnitude of a 1 unit, and coplanar vectors are vectors laying on the same two-dimensional plane, and collinear vectors are the vectors laying on the same one-dimensional lines. So the answer among the given alternative is B, that is the position vector. Okay, two vectors A and B with opposite direction, that means vector A and B have an opposite direction and they are related by A is equal to C times B, where C is any scalar. Then what can be concluded about C? So we can see that vector A and vector B as opposite direction, that means A and B are related by A is the negative of B or B is proportional to the negative of B. Then if I add some constants to get this positive, this C must be negative. So I can say A is equals to minus C of the minus of B, which gives me that C times B. So vector A is some constant times B, so C must be the negative number, or we can conclude C must be negative to get A is equal to C times B if A and B are opposite direction or they are in opposite with each other. So the answer among the given alternative must be C is the negative number on B. Two vectors A and B are given. Vector A is 8i plus j minus 2k and vector B is 5i minus 3j plus k. Then what is the cross product is of b and a? That means b cross a, the values of b cross a. So the values of b cross a means just we write b the first as a first vector and a as a second vector. So we cannot interchange the place of a and b because vector product is not commutative. So I take the components of b first, that is 5 minus 3 and 1, and the components of a as the second vector, that is 8, 1 and minus 2. Then this is equals to, just we know that to get the components of I, which is the component along I, component along j, and the component along k or the z-axis. So from this we know that to get the I component is I cross j with j with k, j cross k is positive and k cross j is negative I. So on both sides I give the I components. So then I cover, just as before, I cover the I. J cross k is minus 3 times minus 2, which is plus 6, and the minus of 1 times 1, which is 1. And to get j is equals to k cross I, and minus j is I cross k. That is k cross I means 1 times 8, which is 8, and minus of 5 times minus 2, which is minus 10. Minus 10, and the k terms are, I cover these parts, and k is always equal to I cross j. Then I cross j is 1 times 5, which is 5, and minus of 8 times minus 3, that is minus 24. So if I do this, I have the 5i, and this is plus 18j, and this is plus 29k. So the values of a cross b is 5i plus 18j plus 29k. So which is on the alternative D. Okay, two forces, 100 Newton at an angle of 30 degrees above x-axis, and another second force is 80 Newton at an angle of 60 degrees. That is, this is, I assume, as F1 and this is F2. Both forces are acting on the object of mass 2 kg. Then what is the magnitude of acceleration which is acting on these objects, or the magnitude of acceleration of the objects due to the forces F1 and F2? So we can do this equation in many ways, but the simplest form is finding the magnitude of the resultant of all the forces acting on the objects. That means we can add force 1 and force 2, either by resolving force 1 and force 2 and then adding their components and find their magnitude and multiply by the mass of the objects to get acceleration, or divide to the mass of the objects to get acceleration, or I can do directly by using the cosine law. That means the F net or the net force acting on the object, magnitude of the net force is the magnitude of force 1 plus force 2 magnitude. So I can do this by using the cosine law. So this is magnitude of force 1 plus magnitude of force 2 square plus magnitude of F1, 2 times magnitude of F1 and the magnitude of F2 cos of theta, where theta is now a smaller angle between force F1 and F2. That is force F1 and F2. So force F1 is at an angle of 30 degrees above x-axis. And force F2 is at an angle of 60 degrees above the negative x-axis. So this is the theta, or the angle between force 1 and force 2, the both. So we can see that 60 plus 30 plus theta is 180. So we can say that 60 degree plus theta plus 30 degree is equals to 180, and then we can find our theta is 90 degree. That means force 1 and force 2 are orthogonal to each other directly. Then the net force, magnitude of net force acting is equals to magnitude of force 1 is 100 Newton square plus magnitude of force 2 is 80 Newton square plus twice of 100 Newton times 80 Newton times cos of 90 degree. Cos of 90 degree is equal to 0 immediately, so this term is 0. So this is equals to, and the radical of this is 10,000 and this is 6,400. So I have 16,400 Newton square under radical. This is equals to 128 Newton. This is the net force acting on the objects. So then the acceleration, magnitude of the acceleration is equals to the magnitude of the net force, divided by mass of the object, which is 128 Newton divided by 2 kilogram. Mass of the object is 2 kilogram, which is equals to 64 meter per second square. So the answer B, which is 64 meter per second square, is the magnitude of the acceleration of the object. Okay, this question requires the angle between vector D and E. So vector D and E have equal magnitude. That means magnitude of vector D is equals to magnitude of vector E. Let's substitute with some number. Let's see, say x. They have equal magnitude x, and the magnitude of sum of the two vectors is 3 times the magnitude of the difference of the vectors. That means magnitude of D plus E is equal to 3 times the magnitude of D minus E. Then what is the angle theta, a smaller angle between the two vectors D and E, is how much? So to do this, exactly we use the cosine rule. That is, we use cosine law. So the magnitude of D plus E means that magnitude of vector D square plus magnitude of vector E square plus twice of magnitude of vector D and magnitude of vector E cos of theta and the radical, and the magnitude of D minus E is also given by magnitude of D square, magnitude of E square minus twice of D, magnitude of D and magnitude of E, the cos of angle between the vector D and E. So this is the magnitude of the sum and this is the magnitude of the differences. So from the equation, magnitude of the sum is 3 times magnitude of the difference. This means we can say that D square plus E square plus twice of D E cos theta is equal to, that means under radical is equal to 3 times under radical of D square plus E square plus minus 2D E cos of theta under radical. So I can take the square of the both sides. I square both sides. That means if these both sides are E squared, so I can take out the under radical of the vectors. So this means that D square plus E square plus twice of D E cos theta is equals to 9 times D square plus a square minus twice of dE cos theta, because 3 square is 9. Since the magnitude of the vectors d and e are equal, I substituted it with x, so I can take x square plus twice of x times x cos theta is equals to 9 times magnitude of d is also x square, and the e is also x square minus twice of x times x cos theta. I take like this. So this is equal to x is twice of x square plus 2 times x square cos theta, which is 9 into twice of x square minus 2x square cos theta. So this means I multiply these together and collect the like terms together, or just we can say that this is equals to 18x square minus 18x square cos theta, which is 2x square plus 2x square cos theta. So I collect the like terms together. That means term with causes to this side and this terms to the other side. So I have 2x square cos theta plus 18x square cos theta is equals to 18x square minus 2x square. If I take or add this together, I have 20x square cos theta, which is equals to 18 minus 2 is 16 is x square. So x square can cancel from each other or from the both side. So I can also simplify here. This by 4 is 5, that is 5 cos theta is equals to this by 4 is 4. So this means that cos of theta is equals to, it is 4 over 5. So this is equals to 0.8. So theta is the cos inverse of 0.8, which is 37 degrees. So the angle between the vectors d and e, the smaller angle between vector d and vector e is 37 degrees. Theta of between d and e is 37 degrees. So the answer is on alternative B, which is so two vectors a and b are given us. A is equals to 2i plus j plus k, and the vector b is I minus 4j plus lambda k. Then what is the values of the lambda if a is perpendicular to b, or if a and b are orthogonal to each other? So we use directly the application of the dot products or the scalar products, or which we call the orthogonality test. If two vector a and b are orthogonal to each other, a is orthogonal to b, then we can say that the dot product of vector a and b is immediately 0. So we find the scalar products of a and b and make equal to 0. That means the a dot b means ax multiplied with bx plus ay by plus az bz. This means a dot b, which is equals to ax and bx multiplied together, we have 2 times 1 is 2, and 1 times minus 4 is minus 4, and 1 times lambda is plus lambda, which must be 0. So then these values become 2 minus 4 is minus 2, which is minus 2 plus lambda is equals to 0. This means lambda is immediately equal. 2. So our lambda is equals to 2, and the answer is on alternative C. So two vectors A and B are given. Vector A is equals to AI plus A radical 3j, and vector B is A radical 3I plus AJ. Then what is the smaller angle? Theta between these two vectors. So to find the angle theta between two vectors, or the smaller angle between any vectors, we use the concept of the scalar product, which says that the scalar product of vector A and B is magnitude of vector A times magnitude of vector B times the cos of the smaller angle between two vectors A and B, theta. Then we are going to find this theta from this concept. That means cos of theta is equals to the scalar product of the vector divided by the product of the magnitude of the two vectors. So to calculate the values of theta, we have to find first the scalar product of A and B and the magnitude of vector A and B. So from the given vectors, the magnitude of vector A is under radical of the x component square, which is a square, plus A radical 3 the whole square under radical, which gives us 2a, and the same is true for the magnitude of vector B, which is a times radical 3 the whole square plus a square, which gives us also twice of a. So the magnitude of the both vectors are equal. So the scalar products of the vectors are a dot b is equals to ax bx plus ay by plus az bz, which is equals to ax is a and bx is a times radical 3 plus ay is a radical 3 times by is a plus az is 0 and bz is also 0. This term is cancelled. A square under radical 3 plus a square under radical 3, which gives us twice of a square under radical 3. So then from this concept we have found both the magnitude of the vectors and the scalar products of the vectors. Then from the first definition of the scalar product, cos of theta angle between two vectors is vector A dot vector B and magnitude of A times divided by magnitude of A times magnitude of B, which is equals to twice of A square radical 3 divided by 2A times twice of A. So this is equals to 2A square under radical 3 divided by 4A square. So A square cancel each other and 2 by 4, which is equals to radical 3 over 2. So this values is exactly equal to 0.8. Therefore theta is equals to cos inverse of 0.8 or cos inverse of radical 3 over 2, which gives us 30 degree. So the angle between vectors A and B is 30 degree. Therefore the answer among the given alternative is D, which is 30 degree. Okay, the magnitude of two vectors A and B are given. Magnitude of vector A is 12 unit and the magnitude of vector B is 5 unit. So among the given alternative, which one is not possible values of the magnitude of A plus B? That means the magnitude of sum of the vectors. So the magnitude of sum of the vectors So the magnitude of A plus B is equals to the magnitude of vector A plus the magnitude of vector B if the vectors are parallel. If A and B are parallel, that means this is the maximum possible value that we can get from the sum of the vectors, or magnitude of the sum of vector A and B. So this is equals to 12 units plus 5 units, which is equals to 17 units. So this is the maximum possible value of the magnitude of the sum of the vector. And the magnitude of A plus B can also be written as the magnitude of vector A minus the magnitude of vector B. This is if the vectors are antiparallel with each other. That means if A and B are the opposite vectors. So if they are opposite vectors, this is the minimum possible values of the sum of the magnitude of A and B. So it is the minimum possible values of A and B, which is 12 units minus 5 units, which is equals to 7 units. So the possible values of the sum of vector A plus the magnitude of vector B can be the minimum, which is 7 units, and the maximum one is 17 units. So any number which exists between two numbers can be the possible values of A plus B. That means the magnitude of A plus the magnitude of B can be exists between these two numbers. That means from 7 up to 17 can be the sum of these two vectors. But any number which is above 17 and below 7 cannot be the possible values of A. So then from the given alternative, we have four numbers: 60, 17, 13, and 7 units. So this is the maximum possible value. This is the minimum possible value. 13 is between these two numbers, but 16 is not between the ranges of 17 up to 7. So this is the only solution which is not the possible value of the sum of vectors A and B. So we can use directly the determinant form. So I means simply J cross K. That means J cross K always gives us A. That means 4 times 5, which is 20, minus 8 times minus 2, which gives us plus 16. And the J terms are J means K cross I always. That means J is K cross I minus 8 times 3, which is minus 24, minus of 7 times 5, which is 35. And the K terms are K means I cross J, which is 7 times minus 2, minus 1, 4, minus of 4 times 3, which is 12. So this is directly equal to 20 minus 16 is 4i. 20 minus 16 is 4i, minus 24 minus 35 is minus 59j, and this become minus 26k, which is on alternative B. The answer is on alternative B. Three students, Abrahat, Baruch, and Chalto, are pulling the boxes by the forces of Abrahat, Fa, and the forces of Baruch is Fb, and the forces of the Chalto is Fc. So if the boxes is in equilibrium, which one of the following is the possible equations of the three forces? So the box is in equilibrium means the F net acting on the boxes is 0. That means force of Abrahat plus the force of Baruch plus the force of Chalto, which are acting on the force on the box is 0. This means that just we can find the force of Abrahat by transferring it to the other side. So minus FA is equals to FB plus FC. So among the given alternative, the correct answer is, which is written on alternative B. That means minus FA, that means the negative of force of Abrahat is equal to the vector sum of the force of Brooke and the force of Chalto acting on the boxes if the box is in equilibrium. The torque produced by the force F at a distances of r from the origin is the cross product of the r and f. That means the cross product of force and the perpendicular distances from the axis of rotation, which is at origin. So directly we can use the Coulomb form or the determinant form. So from this, just I terms are I is always equal to, the I terms is always equal to J cross K. That means we have an I terms which is J cross K, 2 times 4, which is 8 minus, and minus 3 times 3, which is negative 9. And the J terms are J is always equal to K cross I. That means 3 times 2, which is 6, and I cross K, which is 3 times minus 4, which is 12. And the K terms are, K term is, K is always equal to I cross J, that is 3 times negative 3 is minus 9, and 2 times 2 is, which is 4. So this is, the torque is equal to, this number become 17I minus 6J and minus 13K, which is on alternative. So the answer is on alternative C.